Chapter 8, Section 6, Proportions and Similar Triangles. The triangle proportionality theorem says that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. The converse to the triangle proportionality theorem says that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So for the triangle proportionality theorem, we know that the two sides are parallel, and we can use that to say that the two segments created by that parallel line would be proportional. And then the converse, we're going to have a line and we're going to be trying to decide based on a proportion if the line would be parallel to my third side or not. This first example says that in the diagram, UY is parallel to VX. They tell us that UV is 3. They tell us that UW is 18. And then they also tell us that XW is 16. They want us to find the length of XY, or YX. In this case, I would be using the triangle proportionality theorem because they tell me that the two sides are parallel. Before I can set up a proportion, though, I need to go ahead and find the length of just VW. I know that whole side UW is 18. I know that the segment UV is 3, which means that the segment VW is 18 minus 3, or 15. They're asking me to find the length of XY, so I'm going to assign it the variable X. To set up this proportion, I can do it two different ways. I could set up my larger segments, 15 and 6 as a ratio, and set it equal to the smaller segments that are created, 3 and X as a ratio. Or I could write it as the larger segment of UW to the smaller segment of UW, and then set that equal to WX over YX. I chose to do the second choice. I chose to say 15 over 3, which both come from the side UW, equals 16 over X, which both come from the side WY. I'm going to go ahead and simplify. 15 over 3 can be simplified as 5 over 1. You don't have to do that step. You're not going to wind up with the wrong answer if you don't. I just did because it'll keep my numbers smaller, which is kind of nice. When I cross multiply, I get 5x equals 16. Regardless of how you set this proportion up, depending on if you simplified or not, you should get something like 5x equals 16. And when you divide both sides, your final answer should be 3.2. So the length of YX is 3.2 units. And that was an example of the triangle proportionality theorem because they told me that the two sides were parallel, so I could set up a proportion to solve for a missing side length. In this example, it says, given the diagram, determine whether PQ is parallel to TR. If you notice PQ and TR is going from two sides, PS and QS, of the larger triangle, and they've told us the lengths of PT, TS, RS, and QR. What I need to do to see if these two lines are parallel is I need to set up a proportion to see if the two segments created by TR are proportional. The way I'm going to do that is I'm going to write a proportion 26, which would be the length of SR, over 9.7, which would be 9.75, which is the length of RQ. And then I can also set up the ratio 24 over 9, which would be the length of TS over the length of PT, because those two come from the same side of the larger triangle. I'm going to go ahead and write this as a proportion and set them equal to each other. When I have four numbers in a proportion, I'm still going to cross multiply just like I have previously if I was trying to solve for a variable. What's going to happen now is I'm going to have two numbers. There's not going to be a variable involved. If I end with an identity, which means I end with like 2 equals 2, or 3 equals 3, or 3,000 equals 3,000, that means that it is proportional. If I end with a false statement like 0 equals negative 13, that is a false statement, which means these two ratios are not proportional. So go ahead and cross multiply and see what happens. This would be 26 times 9 equals 24 times 9.75. Go ahead and multiply those out, and when you do, you get 234 equals 234. That is an identity, which means that the two sides are proportional to each other, which tells us that, yes, the sides are parallel because the side lengths are proportional, and we were using the converse of the triangle proportionality theorem. The next theorem says that if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. An example of this would be, I have in the diagram, I have PK is parallel to QL, which is parallel to NM, and they ask me to complete the statements. Number 1, they have KL and LM. KL would be corresponding to PQ, and LM would be corresponding to QN, so I could write KL over LM equals PQ over QN, and this is an illustration of the theorem that we just talked about. They also tell me, give me the ratio and want me to write a proportion for the ratio JP and then over PQ. Well, JP would be corresponding to JK, and PQ would be corresponding to KL, so I would write JK over KL. This example says in the diagram, angle 1 is congruent to angle 2, which is congruent to angle 3. They tell me that AB equals 6, BC equals 9, EF equals 8, and they want me to find X, which is the length of DE. What this tells me, by telling me that angle 1 is congruent to angle 2 is congruent to angle 3, they're telling me that corresponding angles are congruent in the transversal. So by the converse of the corresponding angles theorem, I can say that these 3 lines are parallel. And because these 3 lines are parallel, we know that AB over BC would be proportional to DE over EF. Which tells me I could write up the proportion 9 over 8 equals 6 over x. There are several different ways, just like throughout this whole chapter I've been saying, there are lots of different ways that you could set up this proportion. Regardless of how you set up this proportion, you should get 9x equals 48 when you cross multiply. If you don't get 9x equals 48, then your proportion was not set up correctly, and you need to go back and make sure that corresponding parts are in corresponding places in your proportion. When I divide both sides by 9, I get x equals 5 1/3, which would be 5.3 repeating as a decimal. The next theorem says that if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other sides. If you notice, I have in the diagram, I have angle LKM is congruent to angle MKN, and it says use the given side lengths to find the length of MN. If you notice, angle LKN has been bisected by the ray KM. So I can use the theorem that we just talked about. I want to find MN, which would be X. X would be corresponding to the side, which is LN, which is 15 of the whole entire, the outer triangle. And then we would have 17, which would be the length of KN. The way that I'm going to set up this proportion, first of all, LM would be 15 minus X. I'm going to set this up as 3 over 17, which would be my corresponding sides of the smallest rectangle the smallest triangle to the triangle KMN, and then equals 15 minus x over x, which would be my corresponding sides for the middle length sides. When I cross multiply here, I would get 3x equals 255 minus 17x. Go ahead and add 17x to both sides, which gives you 20x equals 255. Divide both sides by 220, and you get 12.75. This next example tells us that FJ is parallel to GI. Find the values of the variables. If you notice, FJ is 9, GI is Y, FG is 2, and GH is 8. And then they tell us they want us to find HI, which is X, and they tell us the whole length, HJ, is 12. Notice that I'm given these two side lengths, FG and GH, which is helpful. I can set up a ratio and I would have two numbers for one ratio, which we need. The whole side FH would be 10, just like the whole side HJ is 12. I can set up a ratio and I can say 8 over 10 equals Y over 9, which I can then cross multiply and I can get 72 equals 10Y, and then 7.2 would equal Y. Well, if 7.2 equals Y, I want to find the length of HI, which is X. The length of JI would be 12 minus X. So I could set up the proportion 2 over 8 equals 12 minus X over X. When I cross multiply, I get, I went ahead and simplified, I'm sorry. 2 over 8 is the same as 1 over 4. So when I cross multiply, I get X equals 48 minus 4X. Add 4x to both sides and you get 5x equals 48. When you divide both sides by 5, you get x equals 9.6. Today's assignment is on page 503. It's numbers 11 through 30 all.